Good evening, everyone. Tonight I'll be going through CHIJ Katong Convent A-Maths Prelim Exam 2019 Paper 2. Paper 1 I did last week, so today I'm going to do the Paper 2. So let's have a look at our first question. The equation 2 to the power of 2y plus k plus 2 equals to 2 to the power of y plus k plus 9 times 2 to the power of y has solution y equals to negative 3. So find the value of k. Alright. So we are given that negative 3, y equals to negative 3 is a solution for this equation. So let's just write that out, okay? So let's take it 1 over 64, because this will be 2 to the negative 6 times 2 to the k. So this is 1 over 64, 2 to the power of k, plus 2. And this is equal to, we'll do the same thing here, this will become 1 over 8, 2 to the power of k, plus 9 over 8. Okay, so we're changing all of our 2 to the power of y. Okay, what I'm going to do here is I'm going to multiply throughout by 64 and I'm going to bring the constant terms together. So I'll just have 2 to the power of k on this side. This will be equal to, so this is 8 now. So this is 2 to the power of 3 times 2 to the power of k. Actually, I don't even need to change this to 2 to the power of 3, but yeah, whatever. Okay, then minus, because don't forget about this 2, I remove this 2, put here, negative 7 over 8 times 64, 56. Okay? Then naturally, we will factorize since we have 2 to the k on both sides. So, then I have 2 to the k, 2 to the third power, minus 1, being equal to 56. And of course, 2 to the third power minus 1 is just 7, which means that 2 to the power of k is 8. K is equal to 3. Alright? For the second part, we need to find the other solution of the equation because there will be two solutions, okay? So coming back here, let's work out our part 2 over here, okay? Let's first change this, okay? Let's first change all of our k's here because now I know that there's going to be a 3 here and there's going to be a 3 here. Alright? So let's figure it out. Part 2, find the other solution of the equation. So I've changed my case to negative 3, positive 3, because that's our k. So what am I going to do now? So we're going to split the terms because I want to get things in 2 to the power of y and form a quadratic equation. I have 8 times of 2 to the power of y squared, right? Plus 2 and equal to, once again I bring down an 8 times 2 to the power of y plus 9 times of 2 to the power of y, right? Alright, so this becomes 17. I bring this over to the left side, then I have a quadratic equation. 8, 2 to the power of y squared minus 17, 2 to the power of y plus 2 equals to 0. Okay? So there's only two possibilities because since this is 2, right? So this must mean that the 2 must become, this must mean that we must have a negative 2 and negative 1, okay? So, because it's 17, so 8 times of 2 to the power of y minus 1 or 2 to the power of y minus 2 is equal to 0. So 2 to the power of y equals to 1 over 8 or 2 to the power of y equals to 2, then y equals to negative 3, which is rejected. This is what we already know, we don't want this. Or y equals to 1. This is the answer we accept. Question 2. Use the derivative of sine x and cosine x to show that d dx cotangent x is equal to negative cosecant square x. Now, we can actually do this if I change this to 1 over tangent and then do the chain rule, but they want us to use the sine and cosine here, okay? Which means that we have quotient rule. So let's see what we get. We will get sine x and then the derivative of the cosine, which is negative sine. minus cosine x and derivative of sine x, which is just cosine x. And all this is over sine square x, right? So all this is, yeah, let's see. So this is negative sine square plus, minus cosine square. Okay? So this will be minus 1 on the top, right? Because the whole thing is sine square x plus cosine square, but together is negative 1 all over sine square x. And of course, this is cosecant, negative cosecant square x shown. So this is quite simple. Even though we cannot use the chain rule, we can still do it with sine and cosine, and we will get this. Part 2. Hence find the gradient of curve y equals to x cotangent half of x at the point where x equals to 2, giving your answer to 2 decimal places. Now, this is a bit weird, of course, because we are not getting things in terms of pi, so we can still find dy dx though. Dy dx is equal to, so this is product rule, x, then cotangent x derivative is negative cosecant square, but I must bring down a half. Alright, then don't forget to put a half, sorry. Half of x, okay, plus cotangent half of x. The derivative of x is just 1. Alright, bring everything together. This is cotangent half of x minus half of x cosecant square half of x. So a lot of tedious things, but we can find dy dx at a certain point when x equals to 2. Dy dx is equal to cotangent 1 minus cosecant square 1, right? Now, of course, this is not going to give you a nice number because this is not in terms of pi. If you press calculator, they want you to give 2 dp, minus 0.77. Okay? Question 3. Peter deposited $540,000 into a bank at the beginning of 1980, which gave a compound interest of 1.8% per annum, which pays directly into his bank account. After a period of T years, the amount of money that Peter has in the bank was given by 540,000 times 1.018 to the power of T. So calculate the amount of money Peter has at the beginning of 1993. Alright, this is one of the things you really should not get wrong, you should really get it right. So part 1, it says at the end of 1993, so we need to change this to 13 years, right? This is literally just press calculator, and this will give us $680,949.45. Okay? Please tell me you can get this 1 mark, if anything, in this whole paper. Part 2. Find the year in which he would have $1 million. Okay. So actually they give 4 marks, but this is much easier than it looks, okay? So we must find a thing that, we must find 1.018. We must find 1.018 to the power of t such that it's equal to 1,000,000 divided by this, which is 50 over 27. Alright, so we are literally just going to find a value of t for which this is equal, and that's it. So if I take ln on both sides, then I can get my t. T will be equal to ln 50 over 27 divided by ln 1.018, right? And if you press calculator, you'll get 34.5. So that means that in 34.5 years, let me break 3SF. So that means that it's going to be somewhere, he's going to take 35 years, okay? So when it's 34.5, it's actually 35. Like, you just round up to 35 and then say, oh hey, it's going to be in 1980 plus 35, 2015. Okay? Even if it was 34.05 or something like that, you still say 2015. Okay? $2015. Okay? So this is the answer, 2015, okay? Part 3. If Peter wants to have $1 million in 20 years, he needs to find a bank that gives a compound interest of R% per annum. Find the value of R. Now they even give you the compound interest formula. Okay. So we need to solve for a certain value of R. Let's write our equation, okay? 540,000 1 plus R over 100 to the 20th power should give us a million. Okay? So let's isolate this. 1 plus R over 100 raised to the 20th power will be this divided by this. Again, is 50 over 27. Alright? So 1 plus R over 100, how do we solve for R? What I'm going to do is I'm going to raise both sides to the 1 over 20th power. This cancels out. Then I will subtract 1, then multiply the whole thing by 100, right? So R will therefore be equal to, so let's take this one at a time, raise this to 1 over 20th power, subtract 1, multiply the whole thing by 100. So 100 times of 50 over 27 raised to the 1 over 20 power minus 1. And if you go ahead and work this out, your R is 3.13 on your calculator, 3SF. Okay? So just showing you the technique, but the last part you will still need to press calculator. Question 4. In the figure, two circles intersect at A and C. AG is the diameter of the bigger circle, ACFG. ADHF and BCHG are straight lines. So show that BD is parallel to FG. It's 2 marks, but I could not find a process that takes fewer steps. It's a pretty long one. There's AG, which is a diameter. Because AG is a diameter, we can say that angle AFG, and by the way, because we have another one over here, we can also say that this right here, this ACG is also 90 degrees. So because of right angle in a semicircle, right? Okay, so I have this and that as 90 degrees. Okay, cool. But what else? I actually have this, right? I have the ACB being equal to 90 degrees as well because of adjacent angles on a straight line, which is this one and this one. Okay, and when you see that you have this right angle in the circle, that means that this is a diameter also. By the converse of right angle in a semicircle, then AB is a diameter of the smaller circle. Therefore, okay, I'm not gonna write this anymore because this is taking too long. I'm gonna write this as 1 and I'm gonna write this as 2, okay? Because I have no space to write this. So I can say that angle ADB equals to 90 degrees because of number 1. And I can also say that angle BDH right here is equal to 90 degrees because of that as well, which is due to number 2. Okay, so finally I proved that these two angles are equal. So now because of all of this, right, now I have to come all the way here. Sorry, Tuka. I gotta come all the way here and I need to write one more line for you guys. By the converse of alternate angles, BD is parallel to FG. Okay? Yeah. This is 2 marks. I think I'm doing something wrong here because I can't find an easier way to do it. I'm not very good at geometry proof either because I never learned the topic. I never professionally learned the topic because I'm sitting for O-level in 2020 because of COVID-19. This topic is out of the paper. Part 2. Show that triangle FGH is similar to triangle DAE. Okay? So what we want is to prove that triangle FGH and DAE are similar. And immediately we can see one angle. So I can just immediately say that FGH, we can immediately say this angle to DAE because this is actually equal to HAC because of angles in same segment, right? Okay, then what we have just figured out earlier was that angle AFG, actually I'll write it as HFG, because HFG is the same as AFG, right? I can say that angle HFG is also equal to this right angle here, ADE, right? FG, or I should, in this case, I need to write it as angle EDA, okay? And we have proven this earlier, so I'm not going to write any reason for it. Therefore, by AA, triangle FGH and triangle DAE are similar. Okay? So this one is a lot simpler once we've done the first part. Part 3. Explain why a circle EH as the diameter passes through C and D. Okay? So right now what we have over here is we have this angle and we also have this angle which we also proved that is equal to 90 degrees, right? So let's write this down. Angle ECH is equal to angle EDH equals to 90 degrees. I'm not going to write any reason because we have already proven those. So by the converse of angles in opposite segments are supplementary, a circle passes through CHDE. I'll just start from C and go this way, okay? So, and then by the converse of right angle in a semicircle, because if I draw the circle here, you'll see that there's actually a right angle here, then EH is the diameter. Okay? So yeah, I really don't know what to say lah. It's like I just write all this down here, but there's probably a few ways that Cambridge will accept this. I'm just doing it for like practice and maybe to help future cohorts that may be watching this video. If there's something that I have done wrong during the course of this proof or the other proofs, then let me know. Part 4. If GA is a tangent to the smaller circle at A, show that angle BAG is a right angle. Alright? That's really easy. So we have already shown that this is a diameter, okay? So we know that AB is a diameter of the smaller circle. Okay? So therefore I can simply say that AB is perpendicular to AG, then therefore angle BAG equals to 90 degrees because of tangent perpendicular to radius. Okay? So that was easy, right? Question 5. Evaluate the coefficient of 1 over x in the expansion of x squared over 2 minus 1 over x all raised to 10. Okay? So first we need to work out which term will have the 1 over x, right? So I know that I'm going to start with this being 10 minus r, and this will be r, right? So we have 2 times of 10 minus r being equal to negative 1, right? Because we want 1 over x. So from here, r is equal to 7, which means that we need the 8th term. T8 is equal to 10 choose 7 x squared over 2 raised to the 3rd power and minus 1 over x raised to the 7th power, right? Okay, 10 choose 7 is 10 choose 7, 10 times 9 times 8, divide by 6, 720, yeah, 120. So I have 120, and then this is 8 x to the 6th power over 8, and then minus 1 over x to the 7th, and this is equal to minus 15 x negative 1. So the coefficient of this is negative 15, right? Okay, so that's quite simple. Part B, obtain the first three terms in the expansion of 3 minus x squared over 2, all raised to the fifth power in ascending powers of x, and hence find the value of 2.995 to the fifth power to 3 dp. So, let's do this. 3 to the fifth power minus 5 times 3 to the fourth power x squared over 2 plus 5 choose 2, 3 to the third power, x squared over 2 to the second power, and so on. So let's see, this is 243 minus 5 times 81, 405 over 2, because there's the over 2 here, x squared plus 5 choose 2 is 5 times 4 times 3, then divide by 3, 20, then this is 27, then divide by 4, 135 over 2, x to the fourth power, and so on. Okay, so then we work out 2.995. So first of all, we must put x squared over 2 to be equal to 0.005, right? Then x squared is 0.01, x is 1 over 10. Okay, so sub this into here. 243 minus 405 over 2, 1 over 10 squared, plus 135 over 2, 1 over 10 to the fourth power. Press calculator, you will get a 3dp 240.982. Okay. Question 6. Prove that tangent x minus cotangent x or over secant x minus cosecant x is equal to sine x plus cosine x. So I will start working from my LHS, and then let's see. So I'm going to change everything to sine and cosine, right? So I'll have sine x over, let me move my equal a bit later, sine x over cosine x minus cosine x over sine x, or over 1 over cosine x minus 1 over sine x. Okay. Of course, I'm going to try to bring them together, but notice that their denominators are the same, so I can cancel them out later on. So let's see what happens. So if I multiply both sides by sine and both sides by cosine, then I'll have sine square x minus cosine square x, or over, and then this will also be multiply both sides by sine multiply both sides by cosine. Then I have sine minus cosine. Okay? And then this is difference of two squares, sine plus cosine, sine minus cosine, which will cancel out at the bottom. So this is sine x plus cosine x, which is the RHS. Okay? Part 2, prove that 1 plus sine theta plus cosine theta whole thing square equals to 2 times 1 plus sine theta times 1 plus cosine theta. Alright, so this is our LHS. So this is a bit tricky because of the three terms. So what I'm going to do is I'm going to let 1 plus sine theta be a single term at first. So I'm going to need a bit of space. So let's just say that this is its own term, 1 plus sine theta squared plus 2, and then just treat this as a single term still, 1 plus sine theta cosine theta, right? Then plus cosine square theta, and then I can proceed to expand this part. So this is 1 plus 2 sine theta, right? Plus sine square theta plus, okay, we can start to distribute this. I have cosine theta, so bring it over here, 2 cosine theta plus 2 sine theta cosine theta plus cosine square theta. A lot of terms expanded, but don't worry about it because it's actually quite simple now. Remember that this is 1. We actually have these two on the opposite ends, but it's equal to 1. At this here, we have 2. Now everything is in 2. I can factor out things. We have 2, 1 plus, alright, 2 sine. So this is sine theta plus cosine. and then sine cosine. Right? So I have a lot of stuff, but that's okay. Now, let's say that I consider this and this. This sine theta on both, I can factorize. Then this is sine theta 1 plus cosine, right? So I have 1 plus cosine theta plus sine theta of 1 plus cosine theta, right? And then notice that I have 1 plus cosine, 1 plus cosine, which means that I can also do the 1 plus sine for the factoring. Then I just have 2, 1 plus sine theta and 1 plus cosine theta. And this is the RHS. Okay? Question 7. The diagram shows a semicircle with diameter AB. AC is a point. Question 7. The diagram shows a semicircle with diameter AB. C is a point on the semicircle. A rectangle DEFG is drawn within the triangle ABC, where DE on the side AB, point F and point G are on the sides BC and AC respectively. So given that AC equals to 8 cm, BC equals to 6 cm, find the perpendicular distance from C to AB, leaving your answer in the exact value form. Okay, I have a diagram here. Let's do this. So this is very easy, right? So I will use my different forms of the half times base times height so that I can find the perpendicular distance, which I'll just write down let the perpendicular distance be D, okay? Then this is very simple, right? Then I can say that 8 times 6 is equal to square root of 8 square plus 6 square times D, right? Because I'm using half times base times height for both of these to half cancel out. This is the base times height. Then I have the base being the right angle triangle, so I have the hypotenuse here. Okay, so I can say that 48 is equal to, and then this here is 10, right? It's one of our common Pythagoras triples. So this is 10 times D. So from here, instantly I see that D is equal to 4.8 cm. Okay, so very easy, right? Part 2. If DG is x cm, show that the area of rectangle DEFG, A square meters, is given by A equals to 10x minus 25 over 12x squared. Okay, so that's actually very simple, although it says 5 marks. You will see that GF is parallel to AB, and the perpendicular height of triangle ABC is parallel to FE. Okay, so because of all this, we will notice that we can set up some kind of system that has something like similar triangles. And basically what I'm going to do is I'm going to find the ratio of C and the perpendicular height basically, and FE. And that will be the same ratio for AB to GF. Okay? And then we multiply GF by X, we are done. Right? So let's do this. So I'm going to say that we can find GF like this. GF is equal to 4.8, because that's a perpendicular height, minus X, which is a FE, all over 4.8, right? So that we can find some sort of ratio, and this ratio will be the same ratio as GF to AB. So from here I will times 10, because that's the length of AB, right? So let's see what we get. Of course, if we split this, you'll just have 1 here. So this becomes 10 minus 10x all over 4.8. Okay, but how do we do this? Okay, let's see. If I times 5, then this is 50 over 24, right? Okay. And of course, 50 over 24 will be simplified to 25 over 12. Therefore, A is equal to GF times X, which is just 10x minus 25 over 12x squared. And this is shown. So although it says 5 marks, this question is very easy once you realize that you can use the similar triangles kind of ratio, okay? Some ratios that you can form because of similar triangles. Part 3, calculate the value of x for which A has a stationary value. Determine whether the stationary value of A is a maximum or minimum. Okay, so this is a very standard question, nothing difficult about it at all. So let's write down our A again. a is equal to 10x minus 25 over 12 x squared, right? So we'll just find dA dx. dA dx is simply 10 minus 25 over 6x, right? Okay, so let dA dx be equal to 0, then this is equal to 10. So let's see. So if I multiply by 6 and times 3/5, then that will give me 10, right? Oh, sorry, 2/5. So if I times 6 here and divide by, okay, sorry, times 6 and times 2/5, then that's just 12 over 5, right? So x, my marker running out of ink, x is equal to 12 over 5. Okay, correct? And from here, let's find d square a dx square to find out if this is maximum or minimum. And this is gone. So this is literally just minus 25 over 6. Which means that this is a maximum because it's less than 0. Okay? Very standard question here. Question 8. The diagram shows part of the curve y equals to negative x cubed plus 6x squared minus 3x minus 10. The curve cuts the x-axis at a, b, 2, 0, and c, and cuts the y-axis at d, 0, negative 10. So show that the tangent to the curve at E, which is 3, 8, passes through D. Okay? So this is normal, this is easy. We just need to find dy dx first, right? So dy dx is equal to minus 3x squared plus 12x minus 3. And this is gone. Okay? So when x equals to 3, because that's where E is, we know that dy dx is going to be equal to, let's just sub in, right? So 3 squared is 9, so negative 27. Okay, then plus here is 36, then this is minus 3, so this whole thing is just 6, okay? So we have with that, okay, we are given that 8, right? 8 is equal to 6 times 3 plus c. So c is equal to negative 10, and because d lies on the y-axis, therefore d lies on the tangent. And I can say this because it is at x equals to 0, I can simply just take the c value, and indeed the y would then be negative 10, and that's exactly where d is. It lies on the tangent. Part 2, calculate the area of the shaded region. So we need to integrate, but we also need to consider that little triangle. If you look at the diagram, we need to get rid of that triangle. So let's consider the tangent first. So I'll have y1, y2, okay? So when x equals to, rather when y2 equals to 0, then we must find x, right? X is equal to, okay, you can solve this yourself. This is 5 over 3. So therefore, area of triangle is half times 10, which is the height, and then 5 over 3. And then over here, you'll see that this is just 25 over 3. Which means that the shaded area is equal to the integral from 0 to, the integral from 0 to 2, right? Of negative x cubed plus 6x squared minus 3x minus 10, but immediately we know that this will become negative because of what we see in the diagram. So let's take the modulus. Okay, then don't forget to minus the 25 over 3, okay? So let's see what we get. So I must have, let's start with this. This is minus x to the 4th power all over 4. Then integrate this. This is 2x cubed minus 3 over 2 x squared minus 10. Okay, and then this is minus 10x, sorry. And then this is going from 0 to 2. Okay, and because of course this is a polynomial with no constant term, the 0 is just gonna cancel everything out. So we just need to, let's don't forget the minus 25 over 3, sorry. So this is simply equal to modulus. Oh my god. The modulus should be on the outside. Okay. So let's see what this is. So if I sub 2 here, then I will get negative 8. Then this is 2 into here, then this is plus 16. Then minus 3 over 2 times 4, which is 6. Minus 6. Minus 20. Okay. Then modulus of this, minus 25 over 3, that's the answer. Okay, so let's work it out. So this is minus 8 plus 16, this is 8. Then minus 6 minus 20. So when I minus 6 from here, sorry, this should be minus 4, right? This should be minus 4, sorry. Okay, so this is minus 4 plus 16, this is 12. Then minus 6 minus 20. Okay, there's 6 minus 20, negative 14. Modulus is 14. So 14 minus 25 over 3. Okay, and then this is 42 over 3. So this one must be 42 minus 25 is 17 over 3. Okay, 17 over 3 square units. Okay, sorry about that little mistake earlier. Question 9. A particle moves in a straight line so that t seconds after passing through a fixed point O, its velocity v meters per second is given by v equals to 3e to the power of t minus 40e to the power of negative 2t. Find the initial velocity of the particle. Okay, I'm not going to write on the board for this one. Sub t equals to 0, 3 minus 40, it's negative 37 meters per second. Part 2, find the value of t when the particle is instantaneously at rest. So in this case, that means that v must be equal to 0, right? So this is equal to that. So take ln on both sides, then I have ln 3, I can split them based on ln rules. Ln e to the t is just t, and this will be equal to ln 40 minus 2t. Make t the subject, I'll bring the t over here, then subtract this using log rules again, I can do this. T is equal to ln 40 over 3 because of the log rules. Okay, or over 3 because don't forget we have 3t. Okay, and of course this is exact, but if you want phi SF, I think it's 0.86342. Yeah. Okay, phi SF. Okay, if you want to evaluate it, but exact form should be this. Part 3. Find the acceleration of the particle when t equals to ln 2. So we need to find the derivative of velocity, right? So a derivative of this is the same. Okay, then when I bring down the minus 2, this becomes positive 80. And that's it. When t equals to ln 2, let's work it out. A equals to, so this one will be 3 times e to the ln 2, which is just 2. So this is 6. 80 times of this. E to the negative 2t is the same as e to the t whole thing raised to negative 2, right? So e to the ln 2 is just 2, and then raised to negative 2, that's a quarter. So a quarter times 80, 20. So 6 plus 20, 26. 26 meters per second squared. Okay, so that's very simple. Part 4, find the value of t when the acceleration is minimum. This one's a bit weird because usually we don't find the derivative of acceleration, we stop there. So there's no letter we can use for that. I'll just write dA dt, which should not be difficult to find, but it's unusual. So it's still 3et. Then I have to bring down the minus again. So minus 160 e to the negative 2t. Alright? So then we have to let dA dt equals to 0, right? And then we will use a very similar thing to what we did with the v. So from here, we will take the ln on both sides, right? So I'll have ln 3 plus t equals to ln 160 minus 2t. Alright? And that just means that from here, t is equal to, very similar thing to what we did above, ln 160 over 3, the whole thing all over 3. And of course, that's the exact, but if you want to evaluate, that is 1.3255 phi SF. Cool? Alright. Part 5. Find an expression for the displacement in terms of t, hence find the total distance traveled in the first 2 seconds. Okay, before we get started, remember that there's actually a turning point for v, which is at t equals to 0.86342, which means that I cannot just integrate this from 0 to 2. Okay, so let's find our indefinite s. So integrate, the first one is still 3e to the t power minus negative 40 divided by 2. Actually, this is positive. Plus 20 e to the negative 2t. Okay, plus c, right? Okay, we need to solve for c. Now, when t equals to 0, we know that s is going to be equal to 0, right? Because it starts from rest at an origin. So when t equals to 0, this is 320. So 23, c is equal to negative 23, right? So we must find the values of s for certain values of t. So when t equals to the turning point, 0.86342, and of course we expect that the displacement will be negative at this point, but that's okay. We'll just take the modulus later. Okay, what is s equal to? You will need to sub it into this over here, but I'm not going to write that out. To 5SF, this is minus 12.329. Okay, I'm obviously not going to work it out and evaluate it right here because that will take too long, right? Okay, then same thing. When t equals to 2, we will find s as well. In this case, s will be minus 0.46652. 5SF. Okay, so the total distance traveled what is it equal to? It's going to be equal to 2 times the modulus of this, minus 12.329, minus 0.46652. And of course, you will be wondering why. Well, it's because when we go down the first time, right, when we go from 0 to this thing, we are going to actually go in a negative displacement, right? But we must take the modulus, so the total distance will be positive. Then we go back up. But we don't know what is going to be the distance between this and 2. But if I can find the distance from 0 to 2, using the property of definite integral, I can then use that to show that the distance, that the total distance traveled is going to be 2 times of this, okay? Minus of when t equals to 2. If you work it out yourself, you will realize that using the property of definite integral, I can do this. Okay, then this is 3SF, 24.2 units. Okay. Alright, yeah, cool. Alright, this is question 10. This is the last question I will go through in this video because the last question, question 11, is linear log graph plotting. I'm not going to do that in this video. Instead, I will have the download link to the paper in the description as usual. So I have decided to attach the solutions for that over there as well. So let's just do question 10. 2 points A and B have coordinates 2, 3 and negative 3, 1 respectively. A point P moves in such a way such that AB and BP are perpendicular. So explain why P lies on the circumference of a circle. Okay? So the best part about question 10 is that it's extremely easy. So if AP and BP are perpendicular, then that means that angle APB is equal to 90 degrees, right? Then by the converse of right angle in a semicircle, APB forms a circle, P lies on it. Very easy, right? Okay. Part 2. Find the radius and the coordinates of the center of the circle. Alright. We are given that A equals to 2 and 3 and B equals to negative 3 and 1. But we also found out that because there is actually a right angle APB and it forms a circle, we know that AB will actually be the diameter of the circle, right? Because you know when you draw a circle, imagine there's a circle here, then you draw the right angle triangle, you will see that this is the diameter, this is the right angle, right? So since AB is the diameter, we can use it to find the center. The midpoint of AB will be the center. So the center will simply be negative half, right? You just add these up and then divide by 2. Same thing for the y coordinate. This one should be 2. Then the radius, you take the midpoint. Okay. I'll have the square root of. So let's find so let's take 2 plus half squared. Okay, because yeah, 2 and negative half. So usually have minus, but this is also minus, so it becomes plus. Then plus 3 minus 2 squared. Okay, let's see what this is. So this is 5 over 2 squared, which is 25 over 4. Then this is just 1. So the whole thing is square root 29 over 4. It becomes square root 29 all over 2. And this is the radius. It is a third, but it is still correct. Part 3. Find the equation of the circle. Alright, that's very easy, isn't it? We already have the center and radius. So what do? We just do the typical thing. So we have x minus this, but this is plus now. So x plus half squared plus y minus 2 squared equals to the square of this, which is 29 over 4. That's it. That's the equation of the circle, right? You could of course write it in the general form, but I don't see the point, huh? And then the very last part. Explain why the tangents to the circle at A and B are parallel. Okay? So this one is also easy. Remember that they are remember that both are tangents, right? So we know that tangent is perpendicular to radius, which means that A and B are both perpendicular. The tangents at A and B. The tangents at A and B are both perpendicular to AB, of course, which means that therefore they are parallel. The tangents are parallel. Very simple, right? Yeah, that's it for CHIJ Katong Convent paper 2. Question 11, once again, the solutions will be uploaded as part of the paper where you can download the link. The download link will be in the description for the paper. Alright, so in any case, that will be it from me for today. Now you may have noticed a few things. You may have noticed that I have received some like messaging notifications during the course of filming this, and you may also have noticed that I actually wore different clothes for the different parts. That's because I actually filmed this over 2 days. I filmed half of the paper in 1 day and my camera stopped working for some reason and it was terrible. So I decided that I would have to film the rest of it another day, and that day is today. So hopefully the video will be up by now. I'm behind schedule, but my hope is that next week I will be able to start on another prelim paper. My plan is to do Fairfield Methodist Secondary School paper 1. So in any case, that's it from me. If you have any questions about this, please let me know. Anyway, that'll be it. I'll see you guys next time, alright? Thanks for watching.